Hello everyone, you are watching Math Majlis with Dr. Khalil. In this video, I'll be taking chapter 2, which is exponents and radicals. So we have three sections in this 2.1, 2.2, 2.3. In the first, that is section 2.1, we will take integer exponents. This is the first section. First of all, let me define what are exponents. Exponents means if I multiply a number a, suppose m times, a is multiplied m times. So this I will write it as a to the power m. So a is multiplied m times. So this m goes to the power and the number which we multiply comes to the base. So this is called exponent or index number. And here a is called base, m is called the exponent or index or power, all meaning the same. For example, suppose 2 is multiplied 5 times. I can write this as a exponent 2 to the power 5. If 3 is multiplied 4 times, then we write 3 to the power 4. So what we are going to do now? Now the exponents are integer. That means they are positive integer, negative integer, and neither positive nor zero integer. So we are considering in 2.1 the exponent, that is the power, where the power is a integer. So let's take the laws of exponents. I will give the laws of exponent and simultaneously I will be solving the exercise also. Let us start with the first law of exponent. If you are given two index number a, m and an, that is a is multiplied m times, a is multiplied by n times. So suppose if we are multiplying two index number and remember the base are same, then I can combine this index number as a power m plus n. That means I will add the powers whenever you multiply two index number. But a power m, what is the answer for this? A power m plus m, because same base. Still the power may be different, the power may be the same, but the most important here is the base must be same. A power m, b power m. This we cannot use the formula number 1, because the bases are different. A power n, b power m. Again, we cannot use because the bases are different. We cannot use formula number 1. Let me take an example from exercise 2.1. Exercise 2.1. The question is here, number 3. 3 power 2 into 3 power 3. So we have to simplify this. So since the bases are same, therefore I can apply this formula. The answer is 3 power 3 plus 3. That is 3 power 6 answer. This is how we use the first law. Then we come to the second law. Number 2. A to the power m divided by a to the power n. That means we are now dividing the two exponents. I can write this as am by an. And if I'm going to apply the law says that same base, because the bases are same, and take the power of the numerator, but take the power of the denominator with negative sign. That is a power m minus n. Another example. If I apply the formula for this, a power n by a power m, then it becomes a power first numerator power and then denominator you have to change the sign. That is plus m becomes minus m. So this is a power m minus n. This is a power n minus m. Because m is down, an is down, therefore it is minus. Both are different. They cannot be the same. And again the same thing. A power m, b power n. I can't apply this formula because the bases are different. Let me take an example which is from section 2.1, number 7. 11 point power 3 divided by 11 power 4. So this is 11 power 3 by 11 power 4. This is 11 power This is 11 power 3 minus 4. Not 4 minus 3 because 3 up, 4 down. Then we have 11 power minus 1. That is 3 minus 4 minus 1. Now we take another example. Here, number 4. 4 power 4 divided by 4. How do we do this? It is 4 power 4 by 4 power 1 because no power, the power is 1. So applying the second rule, 4 minus 1. That is 4 to the power 3. This is what? The example number 4 from section 2.1. So this is law number 2. Coming to the next law, number 3. A power m power n is a power m dot, multiply the powers. So here we have one base a, but two powers m and n. So if I want to simplify this, the law says that you have to multiply the powers. Let me take an example for this. Number 5 from exercise. 2 to the power 2 power minus 2. Let us apply the this particular rule. So what are the powers here? The base no change, the power you multiply. The powers are 2 and minus 2, I multiply. You know that minus into plus, it is what? Minus 2 into 2, it is 4. That's the answer. So this is how we use law number 3. Number 4, A by B, or number 4, A dot B power M. So we have two bases here, A, B, because we have written that in the bracket, but there is only one power. So what happens here is that I open the bracket. When I open the bracket, the power goes to A and the power goes to B. That means it is A power M, B power M. So let's take an example for that. Example number 11 in section 2.1. 12 to the power 3 dot 12 whole power 10. Let's do this. So first of all, whenever you are given a bracket, you have to first simplify the bracket. That means first you simplify this. We have same base. Therefore, I can add the powers. So what is the power of 12? It is 1. So inside 12 power 3 plus 1 power 10. Always first finish the inside, then go from the to the outside. So what is the power of 12? It is 4 whole power 10. Now we are using the formula number 3. That is, we have two powers. I multiply these. That is 12, 4 into 10. That is 12 to the power 40 is the answer. So this is how we solve the examples using the laws of exponents. This is number 4. Coming to number 5. A by B to the power M. So what is happening here? We have a fraction in the base and power M. So what happens? This power will go to the numerator and denominator. That is AM by BM. So I separate it. For example, 2 by 3 power 4. Then this is 2 to the power 4, 3 to the power 4. So I separate it. But I cannot combine these two because the base is 2, the base is 3, which are different. I can't combine, or I cannot use the law number 2. So I leave it as it is. This is law number 5. 6. A to the power minus M means if I bring it down, it becomes A to the power M. That means if you have any number with negative power, which is in the numerator, if I bring it to the denominator, the sign of that is minus, becomes plus. In other words, I can also write like this. AM, if it is in the numerator, I can bring it to the denominator, then it becomes 1 upon A to the power minus M. So this is how we make the what you call the negative exponent to positive exponent. I mean numerator to denominator, numerator to denominator. So we can change the places, but when you change the places, you have to change the sign of the power. For example, this example number 2, 15 to the power minus 2. How we simplify this? This is nothing but 1 upon 15 to the power 2, the answer. This is law number 6. Coming to the last 7, remember a to the power 1 is a. That is, if no power means the power is 1. So that is a power 1 is a. A power 0 is always 1. That is, any number raised to the power 0 is 1, except the a should not be 0. That is, base should not be 0. Other than 0, a can be any number. Means 0 power 0 is not defined. The same way, a divided by 0 not defined. The same way, 0 power 0 is not 1. It is not a number. So that's why we say it is not defined. Similarly, a divided by 0 is not a number. Therefore, we say it is not defined. So with this laws, let us do some examples from exercise 2.1. We have done, let's see number 6. Check. 5 minus 8 to the power 0. So we are asked to simplify this. So I told you that whenever you have a bracket, first simplify the inside the bracket. So what is 5 minus 8? It is minus 3 to the power 0. So what is the base here? Minus 3, which is not 0. Therefore, the answer is what? 1, according to the law. Let's say number 9. 4 square dot 4 cube division 4 to the power minus 4. Let's do this. First question, I can combine this by using the first law because the base are same. So 4, 2 plus 3, division means it is 4 minus 4. See that? I have not taken 4 to the power minus 4 down. I have just written division means it is like this. So I bring it down. So what is the power of 4? It is 5. What is the power of 4? Minus 4. Now the bases are same. I apply the second rule. So 4 to the power 5 minus and minus 4. Because the power itself is minus 4, I write this minus is because of the formula. So opening the bracket, you know that minus into minus, it is plus. That is 4 power 5 plus 4. That is 4 power 9 is the answer. What is the extra question? What is 5 minus 5 power 0? So how to solve this? First simplify the inside the bracket. What is 5 minus 5? It is 0. Power 0, which is not defined. Don't write equal to 1. Let's do example number 14. 3 power 3 division 3 power 4 whole power 5. Let us solve this. This I will write as 3 power 3, 3 power 4, whole power 5. First division I write like this. So since the bases are same, then I apply the rule number 2, that is 3 power 3 minus 4. Don't forget the power outside, it is 5. I did not touch it. I am only simplifying inside the bracket. So what is the power of 3? 3 power minus 1 to the power 5, because 3 minus 4 minus 1. Now there are two powers. So what I will do? I will multiply those powers, that is minus 1 into 5. So what is minus 1 into 5? Minus 5. So since the power is negative, you always make a point that always make the negative exponent as positive exponent. So I can bring this down. When I bring it down, the minus becomes plus. So that is what the answer. Going to the next set of question, that is 15 to 33. Let me do number 16. mn square by m minus 2. So in this case, we are given two index number up, one index number down, and I want to simplify this. First question, can I combine this and this? You can't, because the base of the first number is m, the base of the second exponent is n. They are different. You can't use law number 1. But is it this and this? I can apply the law? Yes. But means what is not changing here is n square, no change, because we don't have a similar index number. So I will write n square as it is. When nothing in the power is always 1. So I apply the rule number 2 for m1 by m minus 2. So m1 because numerator minus because of the what you call the law, and it is minus 2 because the power itself is minus 2. So n square no change because we do have only one index number. Simplify this. N square m open the bracket 1 plus 2. So that means n square m power 3. The answer. Of course, there are many questions are there here. Let me do 19. Check. AB square division d power minus 3. Let's do the simplification of this. We have two index number here, one index number here. But the question is here, this have different base, therefore I cannot combine. But I can write this as AB square by d power minus 3 because division means it is this. Now I have three index number. Look at it. All these three index number has different bases. Therefore, I cannot use law number 1. Nor I cannot use law number 2 also. But I will use one law. That means this, the power of this index number is negative. I can make it positive, and that's my last answer. That means AB square, no change. This I will bring up, then that is the answer. AB square DQ is the answer. We have three index number with no common base. Therefore, we cannot use any law here except changing the power negative to positive. Going for 23. P power minus 4 cube square by P power 2 Q power minus 3. So we are given here two index number up and two index number down. I cannot combine these two index number because they have different base. Here also I cannot combine because they have a different base. But this and this I can combine, but they are up and down. So therefore, the power of P is first the numerator minus the denominator, that is minus 4 minus 2. Now the same way I can apply the formula for Q. So the Q power is up, it is 2 minus of minus 3. So this is how we simplify. Opening the bracket, you know that minus minus means it is plus, that is minus 6, and opening the bracket gives you Q power 2 plus 3 because minus into minus plus. So the answer is minus 6 Q to the power 5. But the power is negative, so I have to make it positive always. So therefore, what is left up? Q5. What is down? P to the power 6. That's the answer. So you can do other example, but anytime if you have any doubts or any questions on solving not only this section, the earlier section or any future what you call topic, please write your comment in the comment. I will take up that question in the next videos. Coming to the last set of question, that is 34 to 38. So I will be doing number 37. The remaining questions you do it. It is x6 y3 by x3 y minus 3 y minus 7 by x minus 3 whole power 10. This is the example number 37. And here we have 3 index number up, 3 index number down, and we have overall power 10. So whenever you have a bracket, first simplify the inside one. So I will first simplify inside the bracket, then finally I will go to the power 10. Now look at this carefully. This x6 I can't combine with anything. I just leave it as it is. So let me first simplify the numerator, that is up. There is no x6. So therefore I will write x6 as it is. Next, this and this index number are same because the base are same. Therefore I can add the powers. So what is the power of y? It is 3 plus minus 7. Power 10, no change. Now look at the down. We have this number. So y power minus 3. I will not do anything because it is a single index number with the same base y. But here and here are the same base. Therefore, I can combine x power 3 plus minus 3. So first I do the numerator simplification and denominator simplification. So what it gives you? This becomes x6. This becomes 3 plus minus is minus 3 minus 7. It is minus 4. And then y power minus 3, no change. 3 plus minus 3, minus into plus, minus 3 minus 3, it is 0. You know that x power 0 is how much? 1. So what is left here? You are left with x6 y minus 4 by y power minus 3 power 10. Now we are left with three index number x6, y minus 4, y minus 3. This I can't do anything. So I will write as it is x6. Now y4, y power minus 4, y power minus 3 I can simplify, but they are up and down same way. I can apply the rule number 2. So y power will be minus 4 minus of minus 3, and don't forget to put power 10. So the power of x, no change, whereas the power of y, minus 4, minus into minus, plus minus 4 plus 3, it is minus 1 to the power 10. Now we have two index number x6, y minus 1, and they are considered the base for 10. So I will take this 10 to this and the second one, that is x power 6 into 10, y power minus 1 into 10. So that means ABM, AM, BM, x6 into 10, this. So I'll continue here. This becomes x60 y minus 10, minus 1 into 10, minus 10. So since it is negative, so I will make the positive. So x6 by y10 is the answer for the question number 31. So with this, I complete the chapter 2 and section 2.1. Thank you one and all.